first attempt at solving this problem. I've written out a bunch of stuff that I need to try and solve it, such as the problem is a woman has a mass of 55 kilograms. What is her weight on Earth? And what is her mass and weight on the moon? And weight is in newtons, according to chapter 5, and mass is in kilograms or grams, or yeah. And so we're going to try and find the amount of newtons she is on Earth, and then the amount of kilograms and newtons she is on the moon. And we know that the magnitude of the weight force is called weight, which is directly proportional to gravity, which means an object on the moon would have 1/6 the weight on Earth, and the mass would be the same in both places. We know that 1 pound equals 4.45 newtons and 454 grams. And we know that mass equals weight over gravity. And we know that 1 kilogram equals 2.2 pounds. And we know that 1 pound is 0.454 kilograms or 4.54 grams. Yeah. Something like that. Yeah. And I just did a couple conversions that were in the book to make sure that I have a guide to solve it. And so now we will solve this problem together. I don't know how to... maybe on the side. Okay, so basically what we're going to do first is we know that this woman weighs 55 kilograms. So we're just going to write down 55 kilograms times 2.2 pounds. I'm not very spicy with conversions, so I don't do them exactly how people do them. 55 times 2.2 is 121. She's 121 pounds, and that is her mass on Earth. And so if we wanted to find her weight on Earth, we would take her mass. Weight equals mass times 4.45 newtons over 1 pound. And her mass is 121, so we can put that in there. And then we just multiply that out. 121 times 4.45 equals 538.45 newtons. And that sounds right because the conversion I did when a woman weighed 90 pounds was 400 newtons. So it makes sense that when she's 121 pounds, she's 500 newtons. So that is her weight on Earth. I guess we didn't even need the gravity. Well, we did need gravity, but we know the conversion already, that 1 pound is 4.45 newtons, so we didn't need to use the conversion. Okay, and then as for part B, we're asked what is her mass and weight on the moon. So let's start with her mass. And her mass is just going to be the same on the Earth and the moon. So actually how we can find weight on the moon is by taking the weight on the Earth, I believe, and multiplying it by 1/6, because weight on the moon is 1/6 of the weight on the Earth. So if her weight on Earth is 538.45 newtons, we multiply that by 1/6, which is a certain decimal point. 0.16 repeated. Let's multiply that by 538.45 equals 89.74. And I actually just checked my answer, and this part isn't from today. However, her weight on Earth is 538.5 newtons, and her weight on the moon is 89.74 newtons, and mass never changes.